Hello and welcome to this keynote session, forming part of the 12th Analysys Mason Telecoms Summit. My name is David McElroy and I work as part of Analysys Mason's online events team. Now, you may have already watched some other sessions leading up to this one. However, I just wanted to run through a few points to make sure that you get the most out of this and all of our other summit presentations. Firstly, please remember that all sessions are on demand, meaning that you can access them in an order and at a time and a date that suits you. We have a selection of keynote and breakout sessions for you to choose from, and you can access all of them via the event homepage. Once you have entered your chosen session, you have the ability to connect with our presenters on social media, such as LinkedIn. You'll be able to access useful resources and download them, and you'll be able to submit questions. Now, keep in mind, as these sessions are on demand, if you do submit a question, one of our presenters or a member of our team will get back to you directly by email in the coming days. Now, once the session has ended, you will be automatically redirected to the event homepage. We will, of course, welcome you to join another session. Now, I have the pleasure of introducing this session's presenters. We have Principal Analyst Adora Okaleke, and we have Principal Analyst Gorkam Yujib. I believe Gorkam is going to kick off the presentation, so Gorkam, I'll pass over to you when you're ready.
Perfect. Thank you very much, David, and hello, everyone. Thank you for attending our presentation, Cloud as the Catalyst for New Operator Approaches to Network and Data. My name is Görkem Yiğit. I'm a Principal Analyst in Analysys Mason, and I'm responsible for cloud infrastructure strategies and multi-cloud networking research programs. So today, with my colleague, Adora Okaleke, who leads the Data, AI, and Development Platforms research, we are going to talk about the cloud-based transformation in operator network and data platforms, and how this transformation impacting the platform building models, established value chains, and emergence of the new ecosystems. So we structure this presentation in three main parts. First, we are going to talk about how cloud is disrupting the way operators design and deploy their networks and applications, and why this is paving the way of creating common digital platforms for a more joint approach to 5G and future services. In the second part, we'll have a deeper dive into operator 5G network cloud platform strategies. We will look at the existing and emerging platform models, their traction and potential trajectories, and how they are leading to the generation of new ecosystems in the market. And finally, we'll discuss how operators are adopting data and AI platforms as platform services that will support the cloud-native networks, IT, and digital services, and the impact of these adoption trends on their vendor ecosystems. So with that, let's start with what is a cloud platform and why is it important for operators' new networks and service ambitions. The IT and the telecoms are on the verge of bringing transformative changes across all industries and society as a whole. The world is becoming software-driven, and AI, metaverse, and edge computing technologies will drive the next internet revolution. In the center of all this, there is cloud, and it is the main substrate of this new digital world. The cloud is a collection of infrastructure, technologies, and applications spread across 5 layers as shown in this slide, and it will support the creation and execution of any type of software applications, networks, and digital services. So the cloud journey in telecoms started with virtualization, and this led to the disaggregation of hardware and software. We are now in the cloud-native phase, which leads to a further disaggregation in the software layer, where applications are being decoupled from the middleware and the supporting platform services. Overall, cloud is driving a major architectural shift from the old way of using monolithic, vertically integrated telecom applications and networks. So we now have all these disaggregated software and hardware layers that need to be stitched together to make it work. And this is the big decision operators have to make. How do we bring these pieces together? And this is a challenging decision because it will have a huge impact on the 5G investments and everything that will follow. However, it is as much as an opportunity as a challenge. We know that the siloed approaches aren't the way forward for truly automated clouds, and operators need their networks, IT, and enterprise lines of businesses to work together in order to succeed in the new digital world. So first time ever, operators have the tools and technologies to achieve this by building common horizontal platforms that not only span their network domains, such as 5G core, RAN, and transport, but also their IT applications like OSS, BSS, and the next generation enterprise and edge applications. So the disaggregation gives operators the control and the choice over how to build this platform based on what is most important to them, to their business objectives, and to their customers. In our cloud and platform services practice, we produce research on all the 5 layers of the cloud. Cloud infrastructure strategies is where we cover the foundational cloud technologies, and we look at how operators are building their cloud platforms and how this is reshaping the value chains and vendor ecosystems. So the focus of CIS is mobile network cloudification, and we are launching a new research program called Multi-Cloud Networking. And it focuses on the cloudification of the fixed networks, such as WAN and transport networks, and I'll talk about this a bit more later on. So let's have a look at where we are in terms of the cloud-native adoption in operator networks and how we expect it will change over time. This chart here shows operators' annual spending on mobile cloud infrastructure, broken down into different technologies, including traditional NFV-based functions, which are referred as VNFs here, physical appliances, and the cloud-native functions, the CNFs, that are based on microservices and run in Kubernetes environments. So what this chart shows is that the overall cloudification of the mobile network is still limited. We are estimating that the network cloud reached around 15% of its total addressable market by the end of last year. By total addressable market, I mean the overall network spending that can potentially be fully shifted to cloud-based networks, whether it is NFV or cloud native. Because there are many physical parts and the network assets that will not be cloudified in the foreseeable future, such as radio antennas, optical units, and so on. So this TAM excludes the spending on those components. So the adoption of cloud-native networks is still in an early phase, and the spending is quite small. While operators, they already invested a lot of money in the traditional NFV technologies that are based on monolithic DNFs, the Vim, and OpenStack-based environments. However, 5G is the main driving force behind the shift to the cloud-native networks, and this starts from 5G standalone core deployments, and it is increasingly moving to RAN. And the 5G RAN will be the critical piece for the cloudification because it's also, the most challenging one. But overall, there are 3 key takeaways here. First, the cloud-native networks going from almost nothing to today to a sizable amount by 2026, just over 25%. And this is a momentous change, and this is going to be much faster than what NFV has achieved in a longer time period. Secondly, this is going to be a long journey. Even in 2026, we are looking at a 40 to 42% with a total network cloud spending of over $30 billion. But this takes a massive change, and also the investment in new networks and operations, as well as the business models, culture, and skills, so that operators, they need to take a very long-term view and vision on cloud native. And finally, cloud native technologies are changing the way operators design, deploy, and operate their networks, and also who they partner with to do this. We are seeing that operators are taking different paths to achieve a more platform-based approach to building their networks, and new value chains and ecosystems are created as a result of this. So now let's have a look at these paths and ecosystems in the cloud-native network landscape. So we've been tracking operator network cloud deals with vendors for a very long time, since the beginning of NFV. And in the NFV or virtualization phase, the large majority of the markets continue to use vertically integrated network clouds. And these are typically procured from major network equipment providers. And it is the model number 1 here. But some technically advanced operators, they embraced a more disaggregated approach to building their clouds. For example, the model number 2 here, where they created a DIY private cloud by procuring network functions, cloud stack, and the hardware from different players. And they're also putting them together by themselves. So pretty much these were the 2 main choices they had. However, in the cloud native phase, things started to change dramatically. Public cloud providers entered the network cloud market. This is the model number 3. They bring their highly automated cloud infrastructure and operations to the telco networks, most often as a managed service offering, and they're also building ecosystem partnerships with both challenger and incumbent vendors for the network functions. So this model is still in the early days, but it's already gained lots of interest and momentum. In addition, we have a new emerging model, number 4, where operators themselves are becoming vendors and platform providers. So basically, an operator packages and integrates a 5G network, which consists of a vendor ecosystem as well as operators' own solutions. So the operator sells this platform to other operators. The prime example is, of course, Rakuten RCP and Symphony, but also Reliance Jio recently joined this category. Overall, cloud is driving more disaggregated options and more diverse ecosystem choices for operators to build their network clouds. All these models offer different advantages and challenges in terms of total cost of ownership, integration and deployment complexity, and vendor lock-in. There is not a single model that prevails all, and every operator has a different starting point. For instance, a lot of operators have their NFV networks, and they're looking at a hybrid environment where there are some greenfield operators, such as Dish and Rakuten. They start fresh with cloud native. And we also see operators using a combination of these models in different network domains and geographies, and I'll talk about it in the next slide. So we are about to publish a report very soon on the market traction of each of these platform models I have described previously. We collected around 100 publicly announced cloud-based 5G commercial deals over the last 2 years, and we looked at who is adopting which model and where in the network. This data includes the 5G core, both standalone and non-standalone, and cloud-based 5G RAN, including vRAN and Open RAN. So I'm showing you the aggregate numbers here in this chart, and the first thing that jumps out is that vertically integrated stacks are still the majority, with 55% of the deployments. However, there has been a very significant decline in this model. In NFV, this number was over 80%, and only 2 years ago it was down to 75%. So there has been a very strong shift away from this model to more disaggregated approaches, and we expect this trend will continue in the long term. DIY private cloud is the dominant model among the disaggregated approaches, and this is mainly driven by large tier ones that are standardizing their cloud architectures with their choice of cloud vendor, such as Red Hat and VMware. However, some of them, like Vodafone, for example, they have variances in different regions and domains. For example, the VMware is the main cloud in Vodafone in many regions, but they're also working with Wind River in its Open RAN network in the UK. But overall, most of these operators have been on this horizontal cloud journey for a long time. They learned a lot from their initial experiences, as well as their challenges, especially in terms of integration and automation. These operators are now evolving their strategies and platforms in order to incorporate the cloud-native technologies, and it will be quite important to see how they will decide to move forward. Especially, they are increasingly getting closer to public cloud providers in enterprise services, edge, and data and AI. Then we have the early movers in public cloud provider-based cloud stacks. We call them PCP-based stacks. And these are primarily for 5G core network, with the exception of Dish, of course. Dish and AT&T are the pioneers in this model. They are working with AWS and Microsoft Azure, respectively. And over the last year, we saw a jump in the number of operators striking network cloud deals with PCPs, and particularly with Google Cloud, who seems to be winning the hearts and the wallets of operators. We know that there are many operators evaluating this approach with PCPs for their network cloud platforms, while there are others that are taking more the wait and see approach. They need to see more evidence and proof points for these clouds before jumping aboard. And this is especially true for RAN, where this model is still a big question mark. And finally, we have a few examples for operator package model. The German operator 1&1 and the Virgin Media O2 are among the first who adopted this model commercially. And also just a few days ago, the Telus announced that it is exploring this model with Rakuten. So the traction is still tiny, but there is a growing interest in it, particularly for RAN. And we are going to have a detailed look at it in the next one. So if we zoom into the RAN, the operator preference for network cloud models show a stark difference. And this is very much expected because the cloudification of the RAN is large part driven by the desire to have more open and disaggregated networks. We recently completed a survey with 75 mobile operators worldwide in order to understand their future plans for RAN. As this chart shows, DIY private clouds will be the primary model, mostly thanks to Open RAN, but a considerable size of operators will initially opt in for vRAN with the incumbents' vertically integrated cloud-based RAN solutions. What's really interesting here is that operators' long-term plans are very different than their short to mid-term plans. We see a big growth in the appetite for operator package platforms and PCP-based clouds. This is signaling that the late 5G and the first wave of 6G RANs may be built differently with different platform and ecosystem approaches in the favor of public cloud providers and Rakuten and its allies. Of course, 4 years from today, it's a long time, and the successes and failures over the short term may reshape the composition of strategies here. But what is becoming clear in the market today is that Open RAN will not be built with pure mix and match strategies. It's going to be an ecosystem play. Early this year, we developed a total cost of ownership study for Open RAN, which is one of the most debated topics in the industry today. And we found that it is possible to build economically viable Open RAN in the macro networks with significant enough cost savings in the short term, for instance, around 20%. But this is only possible with the right ingredients in place, such as a highly optimized cloud platform and a pre-validated and pre-integrated ecosystem around it. This means that operators need to buy into an ecosystem that delivers a complete and consistent cloud platform. And this cloud platform should maximize the performance and minimize the integration and hardware footprint costs. We are already seeing these ecosystems developing by vendors coming from different directions. There are some major players like Rakuten, Mavenir, Dell, and public cloud providers. They are taking the role of open ecosystem leadership, while others are aiming to participate in as many ecosystems as possible, and some want to do both. We are still a few years away from having these complete and commercially and technologically solid ecosystems, but this is the direction the industry is taking. So the cloudification of the mobile network is underway, and operators are building multiple clouds across core, RAN, and IT and enterprise domains. And in some advanced cases, they are doing it horizontally. Multi-cloud adoption is much more mature among enterprises, and many of them are using more than one public cloud service provider, and often in conjunction with several SaaS services. So we are moving towards highly distributed multi-cloud infrastructures, both in telecom networks and enterprises. And this is driving the next step in the evolution of cloud and networks. It is the creation of highly programmable and automated networking fabric between distributed cloud environments, applications, and end users. We are seeing the original principles of SDN, software-defined networking, returning to the WAN and transport networks. And this is driving the emergence of new type of cloud platforms that will be the foundation of enterprise connectivity, network as a service, and the seamless transport in 5G networks. We call this new platform as IP Network Cloud, and it will be built by an open ecosystem of technology vendors in a way that mirrors the disaggregation in Open RAN. So in October 4th, we are launching the multi-cloud networking program that will track this SDN and cloud-native-based transformation of IP network technologies and how this is disrupting the connectivity value chain and the competitive landscape. We look at the multi-cloud opportunity from both vendor and service provider perspectives and assess their progress as they address multi-cloud connectivity challenges. Overall, we expect this new SDN development to transform the connectivity landscape over the next decade. So this concludes my overview of the cloud transformation in network infrastructure, and I'd now like to turn over to Adora for the data and the platform services related discussion.
Thank you. Thank you very much, Görkem, for your presentation. And for the insights that you shared about our research in the cloud and platform services practice. I'll be taking off from here, discussing about how operators are adopting platform services and its impact, and the impact of this trend on the ecosystem partners. So as Gurkhan mentioned, I lead our data, AI, and development platform services research, which I'll be referring to as the DAD program in subsequent sections of my presentation. I'll be given a brief overview of the research which we've been conducting as part of this program. Now, following Gurkhan's presentation, we see operators beginning to leverage the cloud-native architecture to transform both their network and IT infrastructure. Now, while virtualization led to the disaggregation of network and IT applications from the infrastructure, adopting the cloud-native architecture results in further disaggregation, but in this case, at the software layer. Now, we expect this trend to lead to operators experiencing increased complexity in managing these environments and getting them to drive innovation at a much faster pace. Now, this complexity stems from the siloed and monolithic nature of cloud-based applications, such as network functions and IT applications, and their increasingly multi-cloud application deployments. Now, while vendors indicate that their products are cloud native, what they do mean is that these applications can be deployed within containers and orchestrated using tools from the Kubernetes ecosystem. Now, in this case, these applications are cloud native because they are agnostic to the infrastructure as a service and container as a service layers. However, the PaaS layer, the platform as a service layer, which includes the middleware for developing and managing these applications, are still tightly integrated within these applications. In a truly cloud-native environment, the middleware needs to be completely decoupled from the application logic. The tight integration between these components of the application will create a huge challenge for CSPs, especially when it comes to deriving the intelligence required to develop and manage the life cycle of cloud-native network functions and IT applications. Now, in today's cloud-native market, these middleware services are available as a service and can be purchased and consumed by applications that are truly cloud-native. And so the research covered within the DAD research program is focused on understanding how CSPs are disaggregating the middleware from their application logic, whether IT applications or network functions, and the impact of this trend on the partner ecosystem. So this slide tries to put things into context. Operators are beginning to put in place a common cloud infrastructure. In this case, I mean using Kubernetes or a common CaaS layer to run different applications, workloads, including network functions, IT, and customer-facing applications. Now, the middleware and application logic remain tightly integrated. We are also beginning to see a trend in the disaggregation and creation of common middleware environments delivered using the cloud among the most advanced operators. We refer to middleware delivered in an as-a-service model from the cloud as platform services. Our research focuses on data, AI, and development tools delivered from the cloud and consumed as a service. Operators like Vodafone and BT are already building common data environments using GCP platform services, for example. Now, these data environments store and manage data sets that span the entire organization to ensure that data is readily available to support any AI or analytics-related development in any organizational domain that these operators want to undertake. Now, they will also become the data stores for all applications in an operator's environment, including network functions. Leading operators who are adopting these platform services derive many benefits from taking this step. The top benefits being the accelerated pace of development and deployment of new services and applications, and the training of AI models on large data sets. Vodafone is a good example of an operator that has seen the rollout of new AI-based capabilities increase given the use of integrated data and AI platform services to support the enhancement of customer service and network operations. Vodafone recently announced that they have seen an 80% reduction in the time it takes to move AI use cases from proof of concept to production, which equates to a time reduction of from 5 months to 4 weeks. Operators can also foster discipline in the development practices as they have control over the assets used to develop applications deployed within their environment. The Orange Group, for example, has adopted the use of common development toolsets delivered as a service to ensure developer teams use common tools and development environments to support their activities. Now, this benefit will also help to drive the productivity of DevOps teams within the organization. From our research, we've detected a common stepwise approach that most operators take when it comes to adopting data and AI platforms as platform services. Step 1 involves consolidating the operator's existing data environment, although we see operators taking different approaches at this stage. Telefonica, for example, is starting to de-silo its data environment by consolidating data within domains and for specific use cases. For example, its fast OSS data platform consolidates network operational data sets to support internal network analytics and automation use cases. While for use cases supporting new customer-facing services, the operator leverages another data platform within its platform called the kernel platform. Vodafone, in contrast, has ambitiously deployed a single data environment that addresses all use cases across the business. At first, we see operators start to run their siloed data environment on private clouds. But as data volumes increase, they decide to leverage public cloud infrastructure and services. Now, the public cloud enables operators to scale their data environments at a much faster pace than their IT teams can in private cloud. Operators also get access to the constant release of innovative services and features from the public cloud providers. In our discussions with operators, the decision to move data sets to the public cloud is less about the assumed cost reduction, but more about the increased agility they derive from these environments. Now, with data assets consolidated within a common environment, operators move on to invest in common AI platform services. These services often coexist within the same cloud environment where they are provided by the same cloud data platform provider, or they can be provided by a third-party AI platform provider which runs on the same cloud. The key objective here for operators is the integration and direct access that its MLOps practitioners, such as data scientists and engineers, get to a common data environment which eases the development and management of AI models. Most of these activities occur within a single cloud environment. However, as operators' experience of platform services evolves, we expect to see a move towards the consumption of data platform services that span multiple cloud environments. Depending on where operators are on this maturity timeline, they will use different approaches to procuring platform services, such as a common data environment shared by multiple applications. Now, some may take a SaaS approach, the first model shown here on the left-hand side of the slide. SaaS applications mimic traditional applications in that they have platform services embedded within them, as is the case with ServiceNow and Salesforce. But they serve a larger suite of applications and use cases, so they support a limited consolidation of data and domain-specific analytics. However, as operators think through their data consolidation strategies and want to pursue more disaggregated approach to consuming platform services, we see them building discrete data environments in the cloud, either private cloud environments, as shown in the second model, or using public cloud platform services in my third model. Now you can see that there are two flavors to the third model. One using both the cloud infrastructure and platform services from a public cloud provider, as named Model 3A, and one that uses platform services from a public cloud infrastructure agnostic platform service provider, as in Model 3B. Now, all models have their pros and cons. Model 1 ensures operators leverage common tool sets to support applications in a specific domain. However, it creates complexity when operators consume multiple SaaS products because it replicates the current problem of disjointed datasets across applications. The private cloud deployment model gives CSPs the sovereign control over their data environments, but can limit their ability to scale while using platform services from a single public cloud provider to provide the scale and enable operators to tap into their public cloud providers' innovative services and expertise. Now, however, this model will also introduce vendor lock-in. We see several operators using platform services from cloud-agnostic platform service providers to avoid this vendor lock-in. But such services can be expensive and may affect the performance and may create some performance overhead as they are not native to any particular cloud environment. Now, according to our tracker of publicly announced deals showing operators' implementation of data and AI and analytics systems within their operations, we see that Model 3 is the most common model that operators are adopting today. The public cloud provider model is being adopted across operator tiers, beginning with Tier 1 examples such as BT, Vodafone, Orange, Entity Docomo, and Telefonica, and as well with lower tiered operators such as Win3 and Globe Telecom. Now, new brands such as X by Orange also use PCP-based platform services, and we expect continued adoption of this model. So it's clear that there is a stark contrast between what operators are doing when it comes to the adoption of platform services versus where they expect to run cloud-native networks. Now, Gurkham's slide showed that the public cloud deployment model is beginning to emerge for network cloud. But for platform services, this model currently dominates the market. This is mainly driven by the perception that the public cloud providers have more mature offerings for data, AI, and development platform services, whereas they are still learning how to support the network workloads. However, we expect that in the long term, with growing development and acceptance of the public cloud as an infrastructure to support the network, the size of the pie of the PCP-based network cloud platform deployment is likely to increase to look like what we have on this slide. Now, as operators' understanding and experience of these platform services evolves, we expect to see their appetite for more multi-cloud approach to platform services emerge. And this will drive an increased adoption of the cloud-agnostic platform services offered by vendors such as Snowflake, Teradata, and Cloudera. For example, we have operators like Spark New Zealand, and Telefonica with some of its operating companies, and AT&T using these platform services which are offered by the cloud-agnostic platform service providers. Now, we see operators like LGU Plus implementing Model 2 in some circumstances to maximize control over their data, especially sensitive network data, that drives the adoption of this model. This model will appeal the most to operators in regions where there may be fear of infringing data privacy laws or other regulation if data is moved to the public cloud. Some operators in Europe and most in the Middle East and Africa could align with this model. All these models and the operator trend towards the disaggregation of the middleware from application logic pose headaches to telecom application providers. As operators increasingly subscribe to platform services, they will expect their application providers to consume these services as part of their runtime environment. Application providers will need to restructure their monolithic applications that currently use embedded middleware so that they can support their customers' different and varying platform service strategies. Telecom application vendors will also need to evaluate what role they can play in operator software architectures. Now we are seeing two possible routes to market emerge for telecom application vendors. The first is as a platform service consumer. As the name implies, such vendors will decide to consume third-party platform services rather than investing in their own. Our view is that startups building cloud-native microservice-based applications and systems integrators who are creating bespoke applications for their operator customers will fit into this role. The platform service consumers can benefit from reduced development costs and can grow revenues by expanding their suite of applications on top of third-party platform services. But they should also be aware that they need to adopt a more cloud-agnostic strategy. The second role is the second role a telecom application vendor can play which could be a bigger and more influential role is that of an application platform provider. Now, such a vendor would need to offer differentiated platform services to an ecosystem of applications, which could be built by the vendor and also ideally by third-party developers, as seen in the case of Salesforce.com or the ServiceNow model. Now, we believe that vendors such as Amdocs, Netcracker, Nokia, and Subex could all become application platform providers because of their position in the market. And Nokia is already showing signs of moving in this direction with its newly launched Ava platform. However, it's important to note that not all vendors that offer application platforms today are prepared to expose their platform services to third parties, and some have actively taken a strategic decision not to do so. Now, in the long term, this may be a mistake, as all the market indications are that operators want open application ecosystems. And you can have a look at the RIC, at the Radio Intelligence Controller example for us all to see. So to conclude our presentation, we have come up with the following recommendations for both the operators and the vendor communities. Now, the first recommendation we have is going to the operators who will need to follow a common platform strategy across their network domains and lines of businesses. Now, taking this step will be challenging given the changes it will bring to existing operational practices. There are, however, benefits to taking this approach, including the simplification of operations and the tools and the skills that can be built around these common blocks. And this is not only about technology. Operators can also need to gain the buy-in of key stakeholders across the organization by convincing them of the benefits that come with taking this approach. Operators are seeing the value that cloud-native software can bring in driving more open networks and IT operations, but they can only derive these benefits with the support of their vendor partners. Now, the path to enabling a cloud-native environment may be challenging, for vendor partners to achieve. However, to succeed, vendor partners need to transform the current product architectures, business models, and partner ecosystem. And our final recommendation follows a previous point we had raised in the discussion, which is that there are different models and partners that operators will need to decide on adopting when it comes to platforms and platform services. Now, considering now the pros and cons of these models and how they align with your organization's priorities will be critical. The model operators decide to take will also impact on the partner ecosystem they decide to work with. And this partner ecosystem needs to provide offerings that will enable operators maximize their investment in cloud platform services. And on this note, I conclude, this concludes our presentation for today. Thank you so much for your time.
Thank you very much, Adora, and thank you very much, Gorkum, for that insightful and interesting presentation. And thank you to everyone who took the time to join. I would just lastly remind everyone before they go that the slides are available for download along with some other useful resources. You can still submit questions to our presenters. They will pick those up in the coming days, and either them or a member of our team will get back to you in the next few days. And really lastly, I'd just like to thank you very much for joining this session. We hope you found it insightful and enjoyable. We welcome you to join another session. In just a moment, you'll be automatically redirected to the event homepage. Please join us for another. And I will just say once again, thank you for joining, and we hope to see you again soon.